We owe our existence to stellar explosions. The universe didn't start out with all of the ingredients needed to make us. Before stars came into existence over 13 billion years ago, the only existing elements were those that were able to form shortly after the Big Bang. Lots of hydrogen, some helium, and just trace amounts of lithium. That was the periodic table at the time. Ever so slowly though, immense clouds of gas consisting of these elements coalesced under the influence of gravity until they accumulated into things so massive and dense that the pressure and heat within them was great enough to ignite and sustain nuclear fusion. Stars were born. See, fusion is the reaction that gives life to a star. It's when multiple atoms, or rather atomic nuclei, under extreme enough conditions are able to merge and form larger ones. In that process, mass is liberated into lots of energy in the form of light and heat. This is why stars shine and how they generate the outward pressure needed to hold themselves up against the relentless squeeze of gravity. For most of a star's life, it's powered by fusing hydrogen in its core, which produces helium. As it reaches old age though, and eventually depletes most of its hydrogen fuel, it can no longer generate as much outward pressure, and gravity starts to win the fight. The star's now helium core contracts more and more. This compression though causes its temperature to rise and its density to increase until the conditions in it become so extreme that helium begins to fuse, becoming the star's next fuel source to fight off gravity and keep itself up. As a byproduct, it creates an element that didn't exist at the beginning of the universe. Helium fusion produces carbon, one of our main ingredients. Now, if the star is massive enough, 8 times the mass of the sun, fusion doesn't stop there. These high mass stars are capable of forcing heavier and heavier nuclei to fuse. When they run out of helium, they'll begin to fuse carbon, which introduces elements like oxygen, sodium, and neon to the universe. This tug of war between pressure and gravity continues on until the star has forged every element on the periodic table all the way up to iron, where the fusion process stops. You see, iron is the most stable element that exists. And what this means is that it is the end of the line in terms of energy you can get out of nuclear fusion. Fusing iron or anything greater doesn't provide energy, it actually absorbs it. So instead of being yet another fuel source for the star, iron is stellar poison, and when just enough of it accumulates to surpass what's known as the Chandrasekhar mass limit, gravity wins. The core suddenly collapses, and all of the star's outer layers come crashing down as a result. The star then explodes as an outward shockwave, along with countless subatomic particles called neutrinos, blast those outer layers back out into space. And as a result of this supernova explosion, the cosmos is now enriched with a plethora of ingredients. Ingredients that'll go on to form new generations of stars, with planetary systems, equipped with all of the raw materials necessary for life. That's a true story. We actually have exploding stars to thank for the calcium in our bones, the nitrogen in our DNA, the iron in our blood. The stuff that makes up you and I didn't exist before a star made them.